think, my 6th year presenting Scala-related stuff at LinkedIn. So, kind of fun to be back. So, I've written a couple of commercial spreadsheets, 3. I founded the Lift Web Framework project. I've been doing Scala for 8.5 years and doing this for over 8. I also wrote the second book on Scala called Beginning Scala. I've been coding Clojure for about 3 years now, so I'm kind of starting to feel comfortable with it, which might seem strange, but some languages come easily and some don't. Both Clojure and Scala were difficult for me. I recently did some programming in Go. That was really easy, but I'm an assembly language, basic C, C++, Objective-C person from forever, so kind of those imperative languages make sense to me. Or I shouldn't say they make sense to me, they're easier, and I understand what they're doing. Functional programming has always been a little bit of a mind shift for me, but now doing it, it's really hard for me to then go back and look at mutation land. I'm also trained as a lawyer and will wave my hands and blather endlessly about the law. So tonight, first of all, interrupt me with questions. I've got my reading glasses on, so if I don't see you immediately, wave. I definitely do better with a live group than just kind of not. So I'm going to talk about some background on Scala and Clojure. I'm going to do some live coding, thoughts and questions. But ultimately we can take this wherever you all want to go because it's your night too. So Scala, it's a hybrid OO functional language. It's all things to all people. And it's like you can do some of this, you can do some of that. Oh, you want dynamic? Well, you just add the dynamic type in. It's like there's a lot of stuff put into Scala, and given the amount of stuff, it holds together surprisingly well. Scala also has a particularly gnarly type system. I actually put this presentation together for QCon in Beijing, and so that was the first place I did it. And so I looked up the Chinese translation for gnarly, and then I translated it back to English. And it was, absurdly dangerous but inviting activity or something like that. And I'm like, yeah, that fits very well for the Scala type system. And it is, given the constraints, which is you have to deal with subclassing, subtyping, and a whole bunch of other stuff, the Scala type system holds together remarkably well. And at least to my mind, it's easier to deal with than Haskell's type system, but maybe that's because I spent, a substantial part of my life now, almost 20% of my life doing Scala, whereas I spent about a year doing Haskell and then said, I understand why people did like it, but not me so much. Scala has Java-like syntax, which is either a blessing or a curse, depending on whether you came up from Python, or Lisp, or C. And the interop between Scala and Java is excellent. But there are actually, having done some work with Clojure and also more recently with Nashorn, which is the JavaScript engine built into Java 8, I've learned that there were some decisions made about Scala's collection libraries and lack of interop between Scala's collection libraries and the JVM, or the Java util. We shoved this stuff here 20 years ago and kind of stuck libraries that, it makes it difficult if you're outside of Scala looking in. Clojure, it's a modern Lisp and it's a functional language. It is, sorry, I thought it was a community type system. What? No, it's got an optional type system. Actually, it's got a couple of optional type systems. And one of the things that's interesting about Lisps is they've been around so long that, and they've been in academia for so long, there's just a ton of stuff in Lisps that, it's kind of like if you've ever built your house on top of like an Indian burial ground or something. You dig down 10 feet, you'll find some like really interesting bones, and that's kind of like Lisp. So, you go and you look at Racket, which used to be PL Scheme. It's a teaching language, it's a teaching version of Scheme. And not being a list weenie, that Clojure is my first list, I will say, list Scheme, whatever. And, there are probably some people here who are like going to pull out knives and going to stab me to death for saying something like that. Just like Emacs is better than BI. Oh my gosh, So there have been some interesting ports and enhancements from Racket's optional type system into Clojure. And it's very neat stuff. To my mind, the key thing about a good type system is having type inference, and at least my exposure to the typed Clojure stuff, it doesn't have good enough type inference to make it useful for me. And I was spoiled by Scala, and even more spoiled by the time I spent in Haskell land. There's also a very interesting project called Prismatic Schema, which is a test time but not runtime type system. So it doesn't do static analysis of the code. It does dynamic testing as to whether the shape of different pieces of data are the correct shapes. And the kind of types that is possible to describe in Prismatic Schema are radically better than the kind of types that a lot of the type systems that grew up in polymorphism land, polymorphic collection land, are able to express. So for big projects, I really like using Prismatic Schema because it serves as both documentation. These are the expected input types, these are the expected return types, and as tests, which is to a great degree what a good type system will do for you anyway. And if you guys have seen Amanda Locher and Paul Snively's talk on types versus tests, it's a really fantastic talk about it's not really verses, it's like how can you make best use of each of them. Clojure is incredibly opinionated language, whereas Scala is all things to all people. Clojure is very much the opposite, which is the way that you can do mutability within Clojure is extraordinarily limited, and it's clearly delimited in your code. Now, yes, you can use Java types or you have Java classes within your Clojure code, and you throw away all the immutability guarantees. But if you do pure Clojure, all of the Clojure collections are immutable. You don't have mutable and immutable versions of the collections. Now, it's true that you can actually instantiate a mutable version of a collection, but if you try to touch it outside the function in which it was created, you'll get an exception. So for practical purposes, it's built for performance, so you can cons up something very quickly and then turn it into an immutable thing. But for daily use, you always use the immutable data types. It is hard to do that at first, even coming from Scala, but once you get the hang of it, it's a truly beautiful thing. And one of the things I found interesting is I use Clojure to build a compiler. I tend to write languages and write compilers for languages. And even when I try to do that with Haskell, I wound up with a stack of 3-state monads, which is, okay, you don't get mutability, but you get the state monads. So, I would have to lift to certain levels to get to the right state monad, blah, 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 blah. And it was really painful. In Clojure, it was the first time I was able to write a truly compiler using truly immutable data structures throughout, not even cheating with atoms. And one of the things that I like about Clojure is that with Haskell especially, with algebraic data types, a type is both a floor and a ceiling. Whereas in Clojure, when you define a record is a floor, but you can always add different optional fields to the record. But you don't have to define a new type to do it. So you have a really nice, sweet way of enhancing, basically as you write a compiler, you very often start with the parsed AST, and you kind of enrich elements of the AST as you go along. And if you have to think of all those enrichments at the time when you first create the node, it's painful. If you have to do that, point someplace in your compiler where you go, oh my gosh, I'm done with enrichment set A, so I'm going to like take my AST and transform it into something else that is a representation that has all my enrichment places. That's kind of what I wound up doing with Haskell. And with Clojure, it's like, okay, I can have my AST types, and then I can enrich them as I go, and I can then just say, okay, does it have this particular enrichment or not? And it actually wound up being a very, very nice way of writing a compiler. The Clojure Java interop is super excellent, not merely excellent. You can do all the subclassing, superclassing, etc. But the Clojure collections are implement all the standard Java interfaces. So you can pass a Clojure collection off to, an Apache library, and it just works. You don't have to do the implicit or explicit boxing, unboxing, or conversions, which is kind of nice. Both compile JVM bytecode and subclass Java classes, implement Java interfaces. So the similarities are that you have immutable data and collections. In fact, an interesting note, Scala's vectors were based on some really excellent research done by Phil Bagwell, who was for many years a salesperson at DEC. And he retired from DEC, and he started off being a systems engineer at DEC, but they realized when they put him in the field, he was able to close. And so they put him in the field, made a lot of money, he closed, and sold a lot of DEC equipment. But his first love, as with many geeks, was coding. So he retired, he knocked on Martin's door and said, hey, can I come hang out in your lab and do some research? So Phil did a paper with Martin on the immutable vectors of tries, and it was just absolutely brilliant work. Scala didn't implement it first. It turns out that the Clojure team picked it up and said, holy crap, this is good stuff. And they implemented it, and then with the Scala 2.8 collections, Scala got vectors as well. It's super easy to pass functions around in both languages. Functions are just anonymous interclasses for you Java people. By the way, who here has never done Scala or Clojure? So, no? Okay, so everybody's done Scala and Clojure. Okay. Both languages are really, really great for reducing complexity and building both distributed and concurrent systems. And part of that is having immutable data structures, because if you think about a distributed system or a complex system or a multi-threaded system, having guarantees that your data is going to change out from under you is super important. It's like, okay, you pass me a parameter. Think of a distributed, or think of a concurrent system in the same address space, just like a REST service. Okay, I'm going to hand off some data and I'm going to get an answer at some point in the future, or I'm going to get something telling me that I couldn't supply an answer for some reason. Okay, cool. That's a REST service, and we pass JSON to REST. We get JSON back from REST. Both, immutable data in, immutable data out. Clojure is marginally easier for doing serialization for distributed systems because data types are much simpler. But, you pick your poison. And both address the expression problem. Now, when I was doing this presentation for QCon, I realized that speaking to an audience that was primarily Chinese speaking, not English speaking, it presented some challenges, but talking about an esoteric computer science term like the expression problem was really stupid on my part. But I figured I'd repeat my stupidity and see whether it applies better here. So what's the expression problem? This is taken from Phil Wadler's definition, which is you want to be able to define your data types in, let's say, a library, but you want your program to be able to extend those data types without the library having to know. You also want to be able to add functionality to existing data types from a library without the library having to know. And if you have both of those things in a language, then you can do all kinds of amazing things because you're not restricted to the design or the data types or the slots in your data or the way that you treat your data or the way that the program treats the data throughout the program. So let's kind of go through and look at, this was, all I wanted to do is add a method to a library class. And if you've done Java programming, you know you can't do this. And it's better in open source land because you port the project, you have your internal Maven build, you add your methods, maybe you contribute back, maybe your pull request doesn't accept it, I don't know. But you know, it's not fun in Java land. So you have subclassing where you can add new data, but you can't add behaviors to existing data types. You can't add a method in Java. But all we wanted was to add a method. No suit for you. It's the funny part of the presentation. I'm back to not being funny, which is I'm much better at not being funny. In Scala, you can actually add new data with subclassing. Yay. And you can also use implicits to solve the expression problem. So it's the other half. It's like, how do I add a new method to string? Well, you know, string in Scala has all kinds of methods that string in Java doesn't have. And you use them the same way. And, you know, us Scala people know how that's implemented. You say, okay, I want to call a toWombat method on a string. How do I do that? Well, I create my Wombat class that takes a string. I have an implicit function or implicit method that boxes my string up into a Wombat. The Wombat method is called, return value is then placed on the stack, which is like, okay, it actually gets the job done nicely. I think implicits are the worst in the world, but they do have some value here. You also might look at this and go, holy crap, you know, you're creating a whole object that needs to be garbage collected just to do nothing. It turns out that Hotspot does really, really good stuff with this. It may either inline this whole operation, because it can see that within the scope of, you know, a couple of lines of code, the actual object is going to be thrown, the object that was created is going to be thrown away. And if the toWombat method is short enough, it'll actually just be inline. The second thing is that even if there is garbage created, and even if there is a method dispatch that takes place, which is, you know, what, 4, 5, 6 machine cycles, the object allocation is done on stack rather than on heap. Hotspot's good enough to do that. At least it has been from, I think, JDK 6, mid-6s someplace. So, you know, it's really costless. And it is very interesting how you have this huge number of class files that are created by the Scala compiler that Hotspot then sucks in and turns into, you know, 4 x86 instructions. And you know, it was very interesting for me when I first started doing Scala work, and I did a for comprehension, and the for comprehension was as performant as just a raw loop inside a Java method. I was like, how does that happen? You know, you've got maps, you got this, you got that. And it turns out that, you know, if you go through and see what Hotspot does, it's inlining functions, and when you have monomorphic classes, which most of the anonymous functions are monomorphic classes, in other words, there's no subclasses of them, so when you instantiate a particular instance, Hotspot knows that it can do a direct dispatch. It doesn't have to go through dispatch tables. It's like, boom, this is actually, you know, turns into x86, and is pretty much the same as the x86 for my inline Java for loop. So in Clojure, you have subclassing. There are these things called records in Clojure, and records are maps with named fields that are actually also created as Java beans, so they interoperate nicely with Java. But you can add fields just, you know, willy-nilly. Hey, you know, I want a foo field or a bar field, and boom, add it. It's there, and it just works. And protocols are the way of adding functionality to data. So you can actually add a protocol, for example, for string or for something else. And Clojure does the right thing in terms of dispatching, doing a fast lookup. Well, actually, what winds up happening with the covers is a protocol gets turned into a Java interface or JVM interface. Anything that you create that implements that protocol, any classes that Clojure is compiling, it actually just adds that interface. So the first check when you call the function is the parameter an instance of the interface that I know that defines protocol. If it does, then it just does a dispatch right to function, which means it's fast. Otherwise, it does a lookup. The lookups are very well optimized, as many of the things in core Clojure are. So you wind up getting pretty much the same functionality, the same performance out of Clojure's protocols. You get the full answer to the expression problem, which is, yes, you can add new functions to existing Java classes. And it turns out ClojureScript, which is the Clojure compiler to JavaScript, protocols work perfectly well as well, which is kind of fun. So this is actually taken from some of the libraries that I wrote for tonight's demo. And we can, I've got a function that's called 2C. It takes a Scala data structure and turns it into a Clojure data structure. And we can see that the extended iterator, which is one of the Scala types. So if we get an iterator, the 2C function for an iterator, it basically does a lazy build on a sequence. So it takes a Scala iterator, builds a lazy sequence in Clojure so that you'll only get the elements that you're touching. And then the next line says, okay, for a Scala seek, and everything in Scala, almost everything in the Scala collections is a subclass of seek, the seek trait. Subtrait, I don't know, but it extends the seek trait. You basically say, okay, take the sequence that we have, call the toIterator, or call the iterator method, and then call 2C, which will wind up dispatching up to here. So in that way, we get lazy Clojure sequences from any Scala collection. Let's see. So the distributed and concurrent thing, I kind of touched on that earlier. Both languages support easy serializability. Clojure is more easily serializable because when most of your data structures are just maps and lists and strings and a couple of other things, they serialize really nicely. Immutable, it's like REST, data in, data out. So let's do some live coding. By the way, does anybody have any questions? I've been babbling now for almost half an hour. By the way, how long do I have, an hour or a little bit longer? I'll keep talking until you guys like throw things at me. So we're going to actually build an application that goes from a front end written in ClojureScript using an interesting library that sits on top of Facebook's React called Reagent that talks to a Scala web front end that talks to a Clojure data backend. So yeah, it's kind of going all the way through. So one of the things that we're going to do is we're going to define the core HTML template, and the core HTML template has really two things that are important in it. There's a div that contains our dynamic application code, and then there's a call out to a Scala snippet. I'm sorry, lib snippet. Who here has done any lib work? No. Okay. So, no problem. One of the things about Lift is that when I started doing Lift, I basically said I'm going to totally divorce templating from any ability to do Turing completeness. So templates are pure HTML that have markers in them, and the markers are the things that denote where to call out to dynamic logic. But the call out to dynamic logic is purely functional in that the dynamic logic takes the subsection of the HTML that's being worked on, and it returns HTML that's then inserted into the page. So it's function in, function out. Actually, it's technically not purely functional because what the snippets typically do is they look at local state, and so they make a decision about, kind of how to mutate a particular collection based on the local state. The way that lif snippets are set off is data-lif, and then the name of the snippet. So lif dispatch looks up something called actorize, and takes passes in this div, and then inserts whatever actorized returned into the page. So the next thing is, let's go look at, actually let's ignore this for a while. I did this entirely wrong. Let me just actually show you the code. So first thing to do, I've got 3 different windows that have to run. I'm using Linergen, which is the Clojure build tool, rather than using SBT, because it turns out Linergen is much more predictable in the way that it does things. So I actually did the first pass of this in SBT, wound up pulling out my hair trying to get SBT to compile Clojure, but getting Linergen to compile Scala is pretty easy. So the first thing I'm going to do is I'm going to set up a Scala compiler process. And what this is going to do is it's going to go through and compile our Scala code. So let's actually take a look at the Scala code rather than live coding. I'll just show you. Can you guys, make this bigger. Okay, can you all read that? Okay, so this is the actorize snippet, and it actually doesn't do anything particularly dynamic. It just inserts some scripting code into the page. So the first thing you'll notice is tail. And what tail does, lift renders templates as nodes rather than as a collection of nodes rather than as strings. So almost every templating language or templating system you're probably familiar with, it vomits out strings, and you kind of hope you have the right closing tags. With Lift, all of your page is built as a collection of nodes, and it's always kept as a collection of nodes. There's a pass where you go through and you, where Lift goes through it and it does the snippet stuff, the logic. And there's a second pass that goes through it and the page is correctly balanced. So what does that mean? It means that everything, even in the body, that is surrounded by a head tag is moved up to the head. It means that you can move stuff down to the tail, the end of the page, just before the closing body tag, just by enclosing it in a tail tag. So that, it's like back in the days where why slow was actually used. Why slow would say, well, move all your scripts down to the bottom of the page, and you can do that with one simple tag in there. So what we do is we build, Lift also has what still remains as the best server push technology around. And it's based on it's smart about sessions, it's smart about messages that are supposed to be passed both from the server to the client, from the client to the server. So if there's problems with the connection, the messages will be batched up, and then when the client reconnects, the messages will be sent in the correct order. Any messages from the client back to the server, there's retry logic, there's back-off logic, and a whole bunch of other stuff. So you don't have to write the logic in each of your REST calls to say, oh, I got a 500, let me retry that. Lift does that stuff for you automatically. What we're doing in this demo is we're actually using Lift's support for sending stuff to the client using 2 different actors. So the other thing that Lift does, and this is a Lift freeism, you can have a browser side actor that when you send a message to the browser side actor, the message is proxied to the server. and an actor on the server receives the message. And you can also have a server-side message that takes, or a server-side actor that is a proxy to a function on the client side. So that when you send a message to the server-side actor, the right things happen, and magically the parameterized data is then applied to the function on the client side. So it means you don't have to think about plumbing. You think about messages, you think about actors. So you're building a distributed system, but you're not thinking distributed, or you're not thinking about the plumbing of the distributed system. So what we're doing here is we're building a client proxy. And we're saying actor for client, on a server actor for client. So the server actor is a proxy that when you send that proxy message, it's proxy to the client. This is the name of the function to call on the client when the message comes in. When the actor is shut down, we execute some code. In this case, we're going to post a message, and post message is a closure function. So we're going to invoke a closure function saying, sending a pair, a tuple of data. The first element of the tuple is a Scala symbol. Does anybody know that Scala has symbols? Yeah, okay, one guy over there. Two guys, three. Wow! It's widespread knowledge. So we might start using them. So we create a pair of a Scala symbol and then the actor. So this sends a message to the chat server saying remove this actor as a listener. We also create a data filter. So each time a message is sent to the client, before we send it to the client, we do transit right. Transit is a Cognitect library that is implemented for Java, Clojure, ClojureScript, JavaScript, Ruby, Python, I think a few other languages, not Haskell. And what it does is it's a very rich serialization library, but the serialized data looks greatly like JSON, but the fields are enriched. So you can send dates across, and the dates are reified as a correct date type in whatever the target is. So if you send a date type from your browser to the server, on the browser it's a date, on the server it's a time date. If you send a UUID, it gets turned from UUID to a string in JSON, but to whatever the UUID type is in Ruby, and the types are extensible. So what we're doing is we're just saying, I'm not going to send JSON, I'm not going to send a string, I'm actually going to send rich data so that we can figure out what we've received on the client. So it's going to actually be fully reified. In this case, it doesn't really matter, but and then once we've created our client proxy, we're going to post a message to our chat server saying add the client proxy. So we're going to add ourselves as a listener. And then we want to do the opposite, which is create something that when called on the client actually materializes a message on the server. So in this case, we're going to create a server actor, and we're going to handle a JString, a string that we receive, because that's actually what transit, all the transit messages get materialized into strings. There's strings and they look like JSON. And what we'll do is we'll do a post message to we'll invoke post message, and we'll do a transit read on the string. So this basically turns the string back into whatever the data structure was coming from the client. And finally, we're going to return something with the script tag, and the raw script is a function or a variable that contains a function sent to server. So what we said here is client server for the actor that we just created here. So what that's going to do is that's going to create a top-level variable in the browser's namespace with a function sent to server. And we call that function with a parameter. The parameter is transit serialized, sent back to the, no, I'm sorry, it's not transit serialized. Whatever is taken is then sent back to the server. It arrives as a message into this actor, and the actor does the right thing with it. So that's our kind of glue code in Scala. Let's see if it actually compiled. Yes. So the next thing I'm going to do is I'm going to open up two more windows. I'm going to line REPL. So this is going to open up a REPL. Does everybody here know what a REPL is? Or raise your hand if you don't know what a REPL is. You don't know, okay. So a REPL stands for read, evaluate, print, and loop. So you basically have a place where you can type code and have the code executed, which is really nice for doing development line by line. What's really cool about ClojureScript is there's a live REPL that runs in your browser. So you can actually do live code in the browser. But the first thing we have to do is say ns. I go over my code and see where I put a comment. Sorry about this. So I sometimes have Emacs key bindings, sometimes have Mac key bindings, sometimes have Linux key bindings, and you get the idea. I'm all confused. Sorry. Sometimes I've done this presentation. Still a little slow on it. Yeah, it worked that time. I know it did wrong the first time. Okay, so now we have browser window, so if we go localhost 8080. So we're now getting an error that we're trying to post to an unbound function. So we haven't defined our function yet. The other thing I'm going to do is I'm going to REPL in over here so that I can actually compile this code as I'm writing it. So we're going to build our server, and the first thing we have up here is a channel. So you guys know actors. Clojure has channels. And channels are concurrent synchronous processing, CSP. Basically, it's kind of like actors. You basically asynchronously put a message in something, and at some point in the future, something pulls that message off and processes it. The nifty thing about Clojure's channels is that the implementation is this nice, sweet macro. And the nice, sweet macro will basically unbind your code. So you actually write code that looks like it's linear, but if there's any place where you're waiting on a message in the code, you actually release the thread, and then you wind up coming back to the code and executing when the message is delivered. So it winds up being a lot like actors, but you write your code a lot like just regular inline code. So it's pretty sweet. So let's actually define our define host message, which is the thing that we want to do. We're going to have our message. We're just going to ignore it right now. I'm going to do a Control-Shift-M. That's going to load our code. I'm going to be able to reload our page, and boom. So we're actually doing live coding without having to restart anything. So we have our nice live code. Okay. The next thing that we're going to do is we're going to create an atom. And there's def, which defines a symbol, defin, which defines a function, which is a symbol down to a function. Def once says if you're reloading this in a REPL and the symbol already exists, don't overwrite the symbol. So it means that kind of as we're kind of live coding, we're not going to lose some of our top level variables, which is valuable. So we're going to create a list of our chats. We're going to use something called an atom. An atom is a place where we put mutability in Clojure. So atoms can be atomically changed. And the function that changes an atom atomically has to be idempotent, because if you start trying to change an atom and then you put the value in, but the value that was there before, the value that was there when you started the change operation, if that's not the same value that was in the atom when you finish the change operation, the function will be rerun with the new value. So you're actually, it's a nice, simple, sweet concurrency guarantee, as long as you don't do any side effects inside your atom mutation code. And we're also going to do a def once of our listeners, which is once again an atom. The square bracket is a Clojure vector. And I tend to prefer vectors over lists because vectors are more memory efficient. They're also O1 for most of the operations, whereas lists are ON for most of the operations, order N. So the next thing that we're going to do is we're going to defin run loop. And that's going to be our function that actually handles the incoming requests. And I'm going to use the Go macro. So who here has used the Go programming language? One person, two people. So Go, the Go macro in CSP is actually the same thing that Go uses for sending messages between threads. So you can basically listen to a channel or put messages on a channel in Go. And Go is smart about suspending the thread when you're waiting for messages. And they actually wrote their own stack allocation thing around it using the processor stack. So anyway, we have our Go method, and we're going to then do, and what do says is, here are multiple blocks. And the multiple block, so everything in Clojure is an expression, just like everything in Scala is an expression. But when you have multiple expressions, multiple pieces of code, basically something where you have side effects, you can't just have a single expression. So how do you group the multiple things, one of many of which might have side effects, inside a single thing that is an expression? You use do. So we're going to say they match, and this is where we have some fun. We're going to then say, take from our chat server channel. So this is going to pattern match on the next thing that comes into our chat server channel. And if there's nothing available in the chat server channel, the thread will be released. When something becomes available, a thread will be pulled from the thread pool, and the computation will continue. So we're going to pattern match that on add list or listener. So you remember we said we sent a tuple in from Scala, which was the symbol add and then our listener. Well, we've actually done the 2C function that takes a Scala data structure and turns it into a Clojure data structure. and all the products in Scala are converted into vectors in Clojure. Symbols in Scala are converted into keywords in Clojure. So the add keyword, the add symbol in a product in Scala gets turned into a vector in Clojure with the add keyword and then the second parameter. And when we have that message, we're going to do two things. We're going to send to our listener. So we register a listener. We're going to tell the listener what our current chats are. Take last for the. So when we want to dereference an atom, when we want to say, give me the current value, we're not mutating it, we're stating the current value, put an add before it. It's a reader, basically it's a reader thing that substitutes deref if dereferences an atom. And there are a bunch of other things that can be dereferenced as well. So we basically sent our chats off to our listener, and then the next thing that we're going to do is we're going to call swap. There's a convention in Clojure land that any function ends in bang is side effecting. So yeah, you look at your code and go, okay, here's something that's side effecting. So swap, yes sir?
The do here, and when you do mutable stuff, you have to stick it in a do. What's the semantic of do?
The semantic of do is I have multiple lines of stuff that I'm going to execute, and I'm going to return the last one as the value of the block. So you usually use do if you're going to have side effects, because it's very rare that a side effect in operation will also return something that you want the expression to return. So in this case, we're having two side effects. The first side effect is to take our current chats and send them to our listener. And the second side effect is that we're going to update our list of listeners. So we're going to swap in listeners. So it's going to take the current atom, apply a function to it, and then insert the new value into the resulting value of applying the function to the atom. But if the atom is changed out from under us, it will repeat the function until there's no more change. So the function is we're going to conj list. Conj is like cons, except it's got a J. It's actually the smart cons. So depending on what Clojure has polymorphic dispatch, and conj will dispatch on the type and do the right thing. So when you have a vector, it will append a value to the end of the vector. If you have a list, it will prepend the value to the beginning of the list. If you have a map, it will add a pair as the key value to the map. So there's a lot of stuff that conj does. It's kind of I want to add something to my collection, I call conj. It does the right thing. So this is what we've done for our add message. We have our remove message. Yeah? Is there a question?
So conj list is the function that's going to be used by swap?
Okay, swap passes the current value of listeners into conj, current value of listeners, and then parameter. So it's going to basically add LST. I'm overloading the names. I'm really bad at names. But it's going to add the listener to our collection of listeners and then deposit that back in the atom as long as the atom hasn't changed out from under us during that computation. So if we're going to remove our listeners, once again we're going to use swap. And if I was really good at Clojure, I would do this more better. But okay, I'm not. So we're going to remove anything that's identical. Actually, this down to the next one. So we're going to say that anything that's identical between our listener and % is going to be removed from info. So So info is our current collection of listeners. We're going to remove any references that are identical. So like Scala, Clojure's equal function calls dot equal or does equality testing. But if you want to actually do reference testing, in Scala it's the EQ thing, operator. Yeah, I guess it's an operator, even though it's got letters. In Clojure, it's identical. So basically what we're doing is we're removing any references in our listeners that are identical to the listener that we're asking to remove. Yes, sir?
Underscore in Scala?
Yes. And it's actually, the nice thing about Clojure is you can reuse percent and it doesn't increment the parameter placement. If you wanted 2 or 3 parameters, you could do %1, %2, but you could also repeat %1. Yeah, it's like, you know, it's one of those things where Clojure coming a few years after Scala, there's like a little bit of hindsightness that and then we're going to basically say message guard string. So basically if our message is a string, this is pattern matching without case, but should be pretty similar. So we're basically saying, okay, if our incoming message is a string, then we're going to do 2 things. Okay. First thing that we're going to do is do seek. And so lazy sequences are throughout Clojure. So if you do a map, it's actually a lazy sequence and it doesn't get reified until you touch each element. Do seek is a strict operation in Clojure that says, okay, we're going to do this, actually do it, not lazily do it, for every element. And it's kind of like for comprehension in Scala. So we're going to say, for each element in listeners, for each of our listeners, we're going to apply, actually, you know, I should call this LST, just to be rational. We're going to do a send, and we're going to send our listener the message. So this is going to broadcast out a chat message to every one of the listeners. And then we're going to do a swap our chats conj message. So we're going to basically append our message to the end of our chat list. And finally, we're going to say else email, so you know we don't get an exception because we hate exceptions. And finally, at the end of our loop, so after we do our pattern matching, but inside the do, we're going to loop back. Now you can actually do things 2 different ways in Clojure. You could actually use recur, which is what you would do if you wanted to not use up additional stack space. You create an inner loop and you do recur. It's just like tail recursion in Scala. But in this case, we actually want to give up the function and call it again. Because if we change the function out dynamically, if you're in the middle of the Go routine, in other words, if we kind of recompile, if you're in the middle of the Go routine, it actually won't get updated because the live code won't get reloaded. The calling ourselves at the tail will actually, the next time the function is applied, it will be the new code. It was a trick that I learned when I was actually live coding this the first time. I'm like, ooh, that's not good. Finally, we're going to go down here and we're going to say def once, run loop. So what will happen is the function will be called the first time when we compile, but it won't be called multiple times. Because if it's called multiple times, you'll have multiple things trying to pull from the same channel, and you have channel conflict, which, if you do retail, it's a joke. Yeah, as I said, I'm not good with that humor thing. But not very well. So, string question mark. Okay, it's compiled. So now when we reload, yes sir?
Two questions. So what's the type of list that's getting passed to add and remove? Or of LSD?
It's a list of listeners.
Okay.
So in this case, let's actually drill through and take a look at send. Because send is a magic function that I wrote. It's actually uses a protocol. So we can actually extend it outside the code. So we say, okay, if we have a function, then we just apply the function. If we have a function, Scala function 1, we call apply on the Scala function 1. If we have a many-to-many channel, which is a core async channel, then we put the message on the channel. If we have a lift actor, we do bang on the actor. So no matter what, or within this range of types, the dispatch happens correctly. What's even cooler is in my client code, the code that's outside of this library, I can add another sendable, and send will just do the proper dispatching. So it's part of the expression thing where it's like, okay, I can add the send behavior to something else. So if we wanted to do it for an Akka actor, or for a Scala actor, or for a Scala Z actor, or for, what's that Java actor library name?
Java fibers?
Yeah, fibers, whatever, If you wanted to like apply it to a lambda, you could probably apply it to a lambda. So you can just do the polymorphic dispatch here, and the right thing winds up happening. That was your first question. What was your second one?
You must be psychic. I don't remember. I do have two though. So in this case, your Scala code and your Clojure code are both server side, or is your Clojure code Clojure script?
This is all server side code.
Okay.
So the Scala, but we're going to write the Clojure script code in a minute.
Okay. But so the Scala and the Clojure are communicating via an actorish thing, or are they just calling function methods on each other?
So the Scala code, let's go back to actorize. So when the Scala code calls into the Clojure code, we do find bar, which is part of the Clojure library. So you send a string, and you get the Clojure variable that represents that string, or not, or nil if you're speaking Clojure. And a Clojure variable implements the IFN interface. IFN has invoke on it. So every Clojure function, every Clojure variable, every top-level variable can act like a function. And if it actually represents a function, the function is called. If it doesn't represent a function, you get a runtime error because dynamic. So what we're doing here, let's see, when we added our message, we're getting a post message variable. We're invoking the function, and we're passing this value in. So if we go back to our Clojure code, let's see, which Clojure code, we have a written post message. So let's write post message. So this is called from our Scala code. The dash greater than is what's called a threading macro. It will take the first value and passes a parameter to the second value, the second thing, and pass the result as a value to the third thing. It's kind of like dot notation in Scala or Java. So what we're going to do is we're going to take our message, we're going to pass it into 2C. So we're going to take whatever our data structure is and turn it into a Clojure data structure. So it takes our tuple and turns it into a vector. And then we're going to say send bang chat server. So our chat server is up here as a channel. So we're doing the same send, but in this case it's polymorphic dispatch, so the send resolves to the Clojure channel, put this message on the channel. Which, is semantically exactly the same as bang in an actor. Asynchronously put this someplace else and go on with your life.
And in your Scala code, your transit write, is that writing Scala data structures to transit, and then your Clojure interop read is going from transit to closure structures?
Actually, it turns out that everything that's passed through this turns into, it stays closure data structures.
Okay.
So transit's actually just encoded closure data structures. I didn't extend any of the transit stuff to support Scala data structures as well.
Okay.
I could have like threaded this through 2C but well,
I wasn't sure if one was transit writing, the other was closure interrupt that transit read, if there was a reason for the, we'll get the prefix.
I think it was, I have no idea why.
Okay. I thought maybe they do something different.
Actually, let's just go see. There's,
Okay.
it's important underscore.
Okay.
So we now have our chat code is loading. Yay. We don't have anything to see here yet. So let's go write the closure side of the code. I'm over time. Is everybody happy that I'm just like ambling on? Okay, cool, thanks. So the first thing we're going to do is we're going to write our HTML, which actually seems to already be there, but I don't know why it's doing what it's doing. So anyway, we're going to go in and write some raw HTML. And one of the other things that Lyft does very well that we stole from Clojure is CSS selector transforms. So half of Lyft's server-side templating is the snippet thing. The other half is to say, okay, I have some HTML, how am I going to transform it? And there was a project in Clojure land called nlive, which took selector style syntax, CSS selector style syntax, and then for each of the found nodes would apply a function to them. And it was pointed out to me maybe 2 years into Lyft's evolution. At that time, all of Lyft was, or most of the templating in Lyft was done with inline XML, which served its purpose, but got really clumsy and ugly quick. The CSS selector transforms remove all of the XML constants from Lyft code, because you basically could insert variables into Lyft or into a template, because you got the node seek, you got your nodes passed to you, just like the section passed to your snippet. You could then apply a transform to those nodes and return them. So when I went to ClojureScript land using React, who here has used React.js? Okay, not too many people. React.js is actually a totally phenomenal single-page app writing library. Facebook people did a really, really good job with it. The problem is that they've gone back to having all of the HTML content, yes, you guessed it, inside the JavaScript code. And so the ClojureScript library sits on top of that, put the HTML code as closure data structures in a format called pickup, which is an HTML-ish set of vectors. And so I got pissed with that, and so I decided to do the same thing in ClojureScript land that we did in Lyft land, which is do CSS selector transforms. So it's kind of like this recursive circle, things coming back on themselves. But it turns out that CSS selectors on native browser DOM nodes are really simple. There's a single function that you call that says, here's the selector, give me the nodes. And you can then do stuff to them, which is kind of fun. Anyway, so what we're going to do is we're going to build our HTML. We're going to say hi, and then we're going to have, let's put in an HR. We're going to put an input to give it an ID of in. And then we're going to have a button that's called chat. So yay. Oh, the other thing is I've got to start my other REPL. So there's this really, really sweet library that was released about 6 months ago called Figwheel. And Figwheel is a full ClojureScript REPL that does live code updating into the browser and executes all your ClojureScript code from the REPL line in the browser. So you type ClojureScript and boom, it's executed in the browser. And So we are VB connected, and one of the things we can do is we can say JS alert, yo. Yeah, this is very cool. So we're going to reload this just to make sure that we have our latest JavaScript. And the next thing we're going to do is we're going to say, we're going to go look at our client, and let's see, we're going to do a def once. So here's our atom that contains our chats. Here's our page, which returns nothing. But what we're going to do is we're going to say, this is top level. What this does is it actually runs a macro that at compile happens in the JVM. At compile time, we load the chat template, we insert the string representing the chat template into our ClojureScript code, which is then compiled and sent to the browser. So it means that we can update our template, and the template is shipped with the JavaScript code rather than loaded as a REST request or HTTP request. Makes the initial JavaScript load longer, but for single page apps, it makes page transitions instantaneous. Yay. So what we're going to do here is we're going to just say transform, and we're going to take page text. So the transform applies CSS selector transforms. In this case, it's going to be none. And we'll go here, boom, we have our page updated. Notice I didn't have to do anything, the stuff just got pushed. So we're going to apply two transforms to our page. And the first transform is we're going to say, take the LI node and insert as children our chats. So you can see that our little node went away because they're not. But we can go over here and we can say ns, what's your name still? Core. Yep. So we're going to do a swap. Chats, conj, a. Okay. You can see the browser updated immediately. And now I'm going to quit out of here. Wow, that was done with him. Killed both of them with this. Or I'm going to have to start. Actually, yeah, I'm going to start both of them. Sorry about that. I didn't start the Clojure REPL with RL, or the Figwheel REPL with RL wrap, so I wasn't getting like any of my arrow keys, which was making things marginally more difficult. All these things are loading up. Let's go over here, and we're going to add one more transform. So we're going to transform the button, and the button's transform is going to actually transform one of the attributes. So we're going to transform the onClick attribute of the button. We're going to add an onClick attribute. And here we're going to say function. So we're going to find our button, and we are going to then take our button and thread it through. And we're going to get the value from the button. Then we're going to do a transit right, convert the value to transit value. And then JS send to server, which is going to access our send to server variable.
So you have double arrows?
Actually, this is a single arrow because double arrow appends the threaded value to the end of the block because we don't have anything in parentheses to use a single arrow. It's actually one of those things that has bitten me so many times, and it's like, oh, okay, if I'm using map or filter or whatever, I have to use a double arrow, but if I'm using other things, I use a single arrow. There's also this Minecraft-inspired one, which is called like where you have a golden sword, but you put the golden sword and I forgot what I think it's dash less than greater than in the place where you want the parameter to go. So anyway, and then the other thing we're going to do is we're going to do a set bang dot value in. So we're going to basically make the little box thing go away. And let's see if we have. Yes, we have everything. Require run. If it's running. Reload here. Okay, so we're now running our reloaded app, and then so we've got everything to send our chat to the server. Now the only thing that we have to implement is when the server calls us, when a value is pushed, what do we do with that pushed value? And so we're going to say def and receive. Remember how we had the receive function as the one invoked when we got our server proxy. X let message be to read of X. So we're going to do our transit. And then we're going to say con that a sequence of messages. So if we've basically gotten our initial array, we're going to reset bang chats. We're going to ensure that it's a vector because sometimes transit will turn a vector from the client side into a sequence in other links. So that if transit sees sequences and vectors, it's the same thing. And then we're going to say if it's a string, then we're going to swap chats conj message, so we're just going to conj it off. And finally, else nil. Stupid quotes. Yeah. See if we really page works. Okay. This is where live debugging is fun. So we're going to ask SV client or set chats. That we better chat. So if we do a swap bang chats okay, so that's working. We're punching away. So let's try to figure out why our messages are not being received. So I should go in here and say are being appended. I'm not getting sent back out, or we're not receiving them. Weird. Oh, because I can do that. Ah!
You just didn't save it.
Yep. Now let's, just for kicks, go open up another window. Across both of them, and of course, so that's a lot of code. And, yeah, thank you. So, let's see, wrap up. It is in fact easy to convert to and from Clojure data types, and with Clojure protocols, it's nice and extensible and all expression problem solving-ish, which is nice. And the other thing is that the semantic similarities between Clojure and Scala are really, really close. I mean, you know, at the end of the day, Martin and his lab grew up with the same research that Rich and the Clojure folks stole a lot of stuff from, literally borrowed from, to make Clojure. So yeah, a lot of the ideas are the same, the semantics are very similar. And you know, you might want to call something actors over here or CSP over there, but you know, you can get into the Vim versus Emacs debate about which one is better, but at the end of the day, they address very similar problems in very similar ways. They also both do very well for distributed apps. I mean, we kind of saw here, after I remember to say it, that, you know, it's like we actually have a series of tiers. It's not clear where the plumbing is between the tiers, and it doesn't have to be clear for the apps to run correctly. And the JVM mix seems really nice to play together. So that's it. Questions, comments, feedback. I'll take off my reading glasses and put on I can see farther glasses.
How come all the Clojure statements have to be enclosed in parentheses? It seems like excess baggage to me. I don't see what is the value add there.
So Lisp was one of the original languages.
Right.
Lisps are all homoiconic, which means that the data structures that are used within the programs are also the data structures that are used to describe the programs. So it makes macro writing a lot easier because you're actually, when you write a macro, have you done any Scala macro writing?
No, I'm just getting into Scala.
Okay, so if you want to do Scala macro programming, they're actually really powerful, and I've done some cool things with them, but you want to have a nice ball-peen hammer on your desk. The reason you want the nice ball-peen hammer is to bang yourself on the knuckles to make yourself feel better. There are, I don't know, 17, 20, 22 different AST nodes in Scala, and there will be new ones added. With Clojure, the AST nodes that you have are sequence, vector, map, and string and number and boolean. Might be one other one, but you know, it's like it's all very clear data structures. You can apply the same transformations in your macros that you do in your code. One of the projects that I did, I actually wrote a nice transliterator for a Pythonish language into Clojure. You don't get everything you get in Clojure, but you get the ability to hint to somebody and not have them say parentheses. When you get used to it, it's fine. It actually took me 18 months to get used to it, so it's not something that's easy. It's not something that's easy to get used to, but it actually makes logical sense, and when you've done it for long enough, it makes practical sense. Other questions? released anyway.
So, what is the experience of working on Clojure and Scala and switching between the two within a project?
The experience has actually been very good. I did a very substantial Clojure within Scala project last year. I think it was 20-ish thousand lines of Clojure, which is a lot. Having your boundaries drawn is nice. Knowing that nillable things turn into optionable things in Scala land, or box if you're a lefty. Sorry, that was a political joke. But kind of knowing how your data structures, or where you have a delineation, is really important. So in the example that I gave, it was message passing delineation, and the place where I had Scala code could have been passing stuff off to a RabbitMQ server. From a logical standpoint, there was no difference between sending the code to Clojure land and sending the code to Rabbit land, where it's executed someplace else. And if you can conceptualize your code where you have those clear boundaries, where you're going to make something that is in effect an asynchronous call, that's a nice way to delineate, so that when you're thinking about the difference between Scala land and Clojure land, it's no different than thinking about the difference between JavaScript on the browser and Scala on the server, or Java on the server. Trying to interlace a lot of calls in between them, I think, is generally ill-advised. But passing collections and operating on the collections and returning immutable data that can then be reified into whatever the calling language is a pretty good way to go.
And then, like, one other question would be, what do you see as the benefits of using the two together versus using just one or the other?
So Clojure is much better if you're writing small, discrete things that have a very small API footprint. Clojure does not lend itself well to a large monolith. Scala, on the other hand, with the type system, lends itself extraordinarily nicely to either a monolith or collections of libraries that need to have type safety. Clojure code is both dynamically typed and dynamically evaluated. And the particular project that I was working on last year had to do with dynamically introducing business logic into a cluster of servers. And they tried to do that with Scala, and it turned the frequency in which they had to update the code and then do a rolling restart of their servers was tremendous. It was actually it was starting to cost them money, both operationally and in terms of cluster size. So they basically said, okay, how can we reduce the problem of our business logic changes on a daily or weekly basis? How do we introduce that new business logic across a cluster that is pretty static in terms of the definition of how stuff flows through the cluster, but not at all static in terms of the logic that is applied at each phase of the computation, or each phase of the transformation of data as it flows through the cluster. So Clojure was chosen as the thing that could be dynamically loaded without having to do a roll and restart. It's a lot like the Erlang actors versus Scala actors, where you can basically, REPL into an Erlang process, update an actor, and the next time it processes a message, it processes it with the new actor. That's in effect what we wound up achieving that, but using Clojure rather than Scala. I find that with the REPL and with your whole world is maps, it's much easier to write things like compilers, because I'm not worrying as much about adding types and kind of making all my types play well together, looking at each phase of the compiler pipeline. On the other hand, when I go into big projects, Scala is so nice, because I can say, okay, if I change this thing, what's going to break? And the Scala type system is a much, much better tool for writing tests than a lot of things in Clojure land. And unless you have a team that is really test-driven, your closure code is not going to be as easily changeable from an outsider who parachutes in a Scala code. I think that's a long way around saying there's a whole ton of value in both, and picking the right tool for the problem is an important thing to do. But I don't see one language as being better in the absolute than the other. They're each better for different problems.
Would you say that the ad hoc polymorphism that type classes give you addresses the expression problem?
Yeah. Type classes are implicits. So the code that I showed was just the cheapest way that you can get to implicits, but there is a problem with type classes in Scala versus type classes in Haskell. And the problem is the type classes are resolved at compile time rather than runtime. So you have compile time polymorphism but not runtime polymorphism. There have been some times when projects have gotten particularly large that I really wanted runtime polymorphism rather than compile time polymorphism. But that's one of those, I could also whine about the fact that, my watch band doesn't fit just right. It's like, in life annoyances, it's small, and the number of times it's bitten me is very limited.
Compile time picks the site your implicit's going to come from, but at runtime the actual value.
Yeah.
So it seems like you could still swap in stuff if you needed to.
You basically have to add some additional logic to look stuff up, and so you wind up implementing on an ad hoc basis what the Clojure guys have done with protocols. And as in terms of doing hard things, having hard things done in one place by a team that's like spent a couple of weeks focusing on them, rather than, I'll knock together a solution. Well, okay, I just have to add this one more thing, and oh wow, at scale it's like really biting us in the butt. You probably never experienced that problem, but other people have.
Usually on the some religious questions, so which one is better then? Because you said, for example, Clojure is solving the expression problem probably a little bit cleaner than Scala, right? So then on the other side you say that Clojure is better for executing projects than Scala. Then why do you say it doesn't speak better and it's more modular? Because I understand the expression problem, that's exactly the purpose of it.
So, interesting question, and I think having Clojure solve the expression problem allows a small footprint library to be used and extended. So, the example in the code that I showed, which is, okay, I've got a library which has one call, or maybe two calls, 2C and 2S. So 2C takes a Scala data structure and turns it to a Clojure data structure. 2S takes a Clojure data structure and turns it back into a Scala data structure. That's a very small API footprint. But it's also something where polymorphism really helps you, because you have a Scala data structure that is unique to your business that you need to add to this thing, so you don't have to have an additional call every place in your code. Having a lot of Scala libraries, and Lift is a poster child for this, have voluminous both object hierarchies and function calls, or method calls. So if you've ever taken a look at helpers in Lift or S and Lift, both of those things, they have 250, 300 methods on them, which is just, it's a huge API footprint, but the reason it has a huge API footprint is because we use the types as dispatches. So we have different methods based on type signature. Whereas in Clojure, you might only have one function that would serve the purpose of 10 or 15 functions in Scala, because you basically do the polymorphism inside. You do the type dispatch inside. The other thing is that as a programmer, if I have to think about more than 10 or 15 lines of thing, and my compiler isn't going to give me a lot of help with it, it's problematic. So having a Clojure function library that has 10 calls is something I can keep in my head. Whereas having a Scala library that might have 20 classes and 15 methods and 12 traits and that sort of thing, it's easier for me to have my IDE and the compiler remind me about how to use it or how not to use it. Does that make sense to answer your question?
Does type erasure become a problem with dispatch closure?
Not really. I mean, what you wind up doing is rather than you have a list, you have some sort of collection, you operate on a collection, you do the type dispatch inside the function. So it actually winds up being, in a certain way, nicer because you can do the polymorphic dispatch inside the map, inside the function that you apply to map rather than in the map call itself. So let's say you have a collection in Scala that winds up being typed as list of object. You're gonna have to, you're gonna have to do the dispatch somehow in Scala, whereas in Clojure you can use the protocols, and you can even have either a null protocol or catch an exception to say, okay, I didn't know how to process this. And if you do mapcat, which is flat map, you can basically return a collection or nil if you want to get an exception if you don't know how to handle it.
Is it using like is instance of, or is it signable from, something like that?
I have no idea. If I had an infinite amount of time, I'd probably actually look at the code. All I know is that there are actually two nice things about the Clojure Clojure language development infrastructure. They focus on each release on a couple of performance hotspots and improve them. So many years ago they took care of the polymorphic dispatch stuff, and by all accounts it's fast. There's also a continuous integration server that runs a three-dimensional matrix of JVM version, Clojure version, and popular libraries. So they're constantly testing everything, and so very early in the development phase you'll figure out whether or not a change to the core Clojure stuff or a change to the JVM breaks 50 or 75 libraries, which is really, really nice. And the other thing about Clojure is you don't have the version fragility problem, so that you can use there are many libraries in Clojure that were developed against Clojure 1.3 and never updated, and they still work. You don't have to go, oh wow, this is like, Scala 2.9.3, oh crap, I'll be using 2.9.4.
Also, another thing which was unclear for me, you said that you like Clojure because you can decorate your ASTs easier and add all sorts of things but I don't think that would create all sorts of troubles, right? Like if you decorate the AST with some random things, artifacts, and then later on try to make sense of the whole thing, right?
So
why would you do that?
So using Prismatic Schema, it's a way of basically saying this is the shape of the data that I'm expecting, and it's also a way of documenting the shape of the data. So when I've done compiler work in Clojure, I've also used Prismatic Schema to remind myself of the data structure that each particular function is expecting. So I think of it as structural types versus name types. So Scala and Java and all most of the languages that we're used to use name types. OCaml uses structural types, which is, I don't really care what the name of this thing is, as long as it has the following functions and the following data slots, I'll take it. And Prismatic Schema allows you to define structures that are, or define parameters for function in and function out that are based on the structure of the data rather than the nominal type of the data. In terms, the other thing that's really, really nice about Clojure that I've never seen in any other language is how null-friendly it is, or null-friendly it is. So null is a commonly accepted thing that you pass around. And so when you look up a value and the value's not there, it just returns nil, and your program doesn't blow up, it just returns nil. And there's a lot of functions that you can call with nil as a parameter, like almost all of them. And if you pass in nil as a parameter, they'll return nil. It's like, yeah, okay, you're not giving me anything, I'm not going to blow up. Which is a lot nicer than having null pointer exceptions. So null might have been a $1 billion mistake, but the Clojure folks, the way that they've written their libraries, have made it nice. So when I decorate, when I kind of add stuff to an AST and decorate it with random stuff as it's going through the pipeline, if that random stuff isn't there, the program actually generally behaves correctly. It's like, oh, okay, it isn't there, rather than, oh crap, it's not there. I'll throw. Other questions I've got?
Yeah, so I've heard some criticism about Scala Akka actors that they don't compose, and they create kind of like a coupling between the producer and the consumer. So do you think that the Clojure channels solve the problem in a better way?
I like Emacs better. There's, yes, at the end of the day, any to unit is not the best type signature, but unless you're living in Pure Land, you have that type signature someplace in your code. And having spent a lot of time with Haskell, or not a lot of time, but enough time with Haskell, I've realized that purity isn't, like trying to isolate stuff into the IO monad is not really the best answer. And the way that Clojure points you to state, but is generally functional, tends to be a better answer. But there are side effects, and whether those side effects are expressed as a message to an actor that's handled by a handler, or a message to a channel that's being drawn from a bunch of other channels. And I think there's like one too many actor thingies in the Akka library, so that a lot of the fan out, a lot of the stuff that you're going to do with Clojure CSP is already there. It just is one extra line of code. And I'm usually not always a fan of one extra line of code, but at this, kind of in my mind, it's not the worst thing in the world. And a lot of people have done some nice things with Akka actors, and at least coming from Java land, they present a nice way to write the code. Or a nicer way to do concurrency. Let's see, do we have time for more information?
Question was about the atoms you use. Did you use them on the client side or the server side? And are they also just an improvement on Java atomic workers?
So, yes, they were used on both sides. So, as much as possible, the semantics in Clojure script are identical to the semantics in Clojure. The atom is a thin layer on top of atomic references in Java util concurrent, but the atoms do the swap function and the reset function and some of the other stuff do the right thing with atoms to make sure that your the value that you're putting in is based on applying a function to the value that was gotten out. So it basically replaces some boilerplate code that you would otherwise write in Java. The other thing about atoms that we didn't see here is you can add listeners to atoms. So when the atoms change, the listeners asynchronously on a separate thread get a message with the old value and the new value. There are also validators on atoms, so if you try to put an invalid value in an atom, you get an exception, which is runtime type-ish something. Let's see if anybody else has questions, or actually, why don't you and I just have a chat after?
Can you cite some production uses of Clojure?
Let's see. Apple is using it in the iTunes library, or in the iTunes store. Climate Corp was sold to Monsanto for $850 billion. Sorry, $850 million last year. They're a pure Clojure shop. Walmart Labs is a pure Clojure shop. Let's see, Staples Labs bought one of the local Clojure consulting shops. They're moving towards being pure Clojure. There's a substantial amount of Clojure at Twitter, but then again, what language isn't at Twitter? In terms of ability to hire developers, Clojure is 2 or 3 years behind Scala as a language, and it's 2 or 3 years behind Scala. As an ecosystem, things are far more mature in Clojure than they are in Scala. The three-dimensional matrix of running tests of Clojure versus a whole bunch of other stuff is something that TypeSafe still hasn't done. It was something that Paul Phillips and I tried to do 5 years ago. So there's the Clojure guys. They have the advantage of dealing with a much smaller. They're trying to do something that's much smaller, but they're being a lot more diligent about what they're doing. Whereas Scala is much bigger, and when you have a Scala-ish problem, there's nothing better. But there are so many annoyances like SVT, like version fragility, like that. If there are kind of negatives to adopting Scala as well. But Clojure developers are probably going to cost you 15-20% more than Scala developers. That'll change. Great.
Yeah, actually, can you tell us a little bit about editor support, especially when working with like 20,000 lines of code? How does it work? Things.
Emacs, there you go.
Well, on Emacs there is Enzyme, and it's for Scala.
Okay.
What about Clojure? Do you have at least go-to definition, or keep 20,000 lines of code in mind?
There are a lot of Clojure is a Lisp. Emacs is built on top of Lisp, and the original editor support in Clojure was Emacs. Then there was VI, and there's quite good support in the language for both, or quite good support in the editors for both. Recently, 18 months ago, there was a project called Cursive that started up, and it is an IntelliJ plugin that is the single best IDE tool outside of a Java IDE tool I've ever seen. So you have go to reference, you have find all references, you basically have everything you would expect in an IDE, and it's fully integrated. It was actually what I was using tonight. It's fully integrated with both Clojure and ClojureScript, fully integrated with the REPL. It's a thing of beauty. And it's interesting to see a lot of the old guard, Cognitech. Cognitech is the company that supports Clojure. A lot of the old guard Cognitech people are starting to move over to IntelliJ and Cursive. It's absolutely phenomenal. Okay, one last question. I'm going to be having a nice discussion with the gentleman in red and probably give Steve a ride home. Well, thank you all for coming. Thank you for your awesome questions.